Welcome everybody to another common support video. This one is on equations with variables on both sides, including decimals and fractions. All right, let's see if we can get this to be comfortable for everybody. Let's go. All right, so let me zoom in here a little bit so you guys can see the equations a little better. There we go. All right, so this one is, let's see if I can copy it. I don't think I can, but it's not going to work. All right, so this one is 2 plus 1.25f. I'm going to have to copy these over, so let me just do that. So number one here is 2 plus 1.25 f equals 10 minus 2.75 f. Now remember, you guys have choices when doing this. You can decide to get rid of the decimals by multiplying by the smallest denominator that the decimals would have, or a multiple of basically 10, 100, or 1,000 that's going to move the decimal place enough places to get rid of the decimals. Or you can just work with the decimals and use your rational number skills. Make sure you line up your decimals when you do your math. Make sure you do division properly with decimals. It's really up to you how you want to approach this one. I personally like just to get rid of the decimals. I think it's an easy step. Just multiply the equation by something to get rid of all the decimals and then work from there. So in this particular case, what I would do first is I would multiply the entire thing by 100, because you can see this one's hundredths, right? And this one's hundredths. So that means if we multiply everything by 100, it's going to become a whole bunch of integers, right? So you get 100 times every term across both sides of the equation. So that means 100 times the quantity of 2 plus 1.25f, and 100 times the quantity of 10 minus 2.75f. And since you're basically multiplying the value on the left and the value on the right, you're going to distribute through all of those, which means every single term gets multiplied by 100. Okay, that's the really big key there. Make sure you multiply every term across the entire equation by 100. So 2 times 100 is 200. 1.25f times 100 is 125f. So we're going to add to that 125f. And then you have over here 100 times 10 is going to be 1,000. And then 100 times negative 2.75f is going to be negative 275f. So now you have recreated this equation, right? You've done 100 sets of this relationship. And by doing so, you've gotten rid of all the decimal parts. All those are gone. And now you're just focused on solving this equation. Now, in this particular case, you had 0.25 and you had 0.75. You probably could have just multiplied everything by 4, because this is 3/4 and this is 1/4. If you multiply everything by 4, you'd also be able to solve the problem. And I'll show you that as an alternate later on so you can see how you can play with these different things. Okay? Well, let's first solve it this way. So if we're going to solve it this way, we can say we'll get all the variables to one side and all the numbers to the other. And you can either bring the negative 275f to the left, making it positive 275f, or you can bring the 125f to the right and basically subtracting 125f from both sides. I always think it's a good idea to bring it so that your f's or your variables end up being positive, whichever way that is. So I think it's better to get rid of this negative 275f. So what I would do is I would add 275f, not to one side, but to both sides. So you're going to add that to both sides, and that's going to give you a 0 pair over here, and leave you with the result over here on the left-hand side. And I, at the same time, would then get rid of this plus 200, because your goal is to bring all your variables to the left, or to one side, and all the constants or values that are numerical to the other side, because you want to get the variable by itself, right? So I would get rid of this plus 200, so I'd add negative 200 to both sides. And now this is a 0 pair as well, okay? So ultimately, after doing those moves, we're going to be left with the result here of 1,000 minus 200, which is going to be 800. And on the other side, we're going to have the result that is 125f plus 275f, which is going to be 300 plus 100, so 400f. And we know that these two values must be equal to each other. Okay, so now you have 400f equals 800. How do you undo times by 400? You would divide both sides by 400, because you want to get not the value of 400 f's, but you only get the value of 1f. So 400 over 400 is 1, so there's your 1f. And 800 divided by 400 is just 2. So the answer is that f is equal to 2. And you can just plug that back in and check. What's 2 times 1.25? That's going to be 2.5. 2.5 plus 2 is 4.5. So on the left, you have a value of 4.5. And on the right, you have 10 minus 2.75 times 2. Well, 2.75 times 2 is going to be 4 plus 1.5, so that's going to be 5.5. This is 10 minus 5.5. Well, 10 minus 5 is 5, minus the 0.5 is 4.5. So that is also 4.5. So we can see that it works out perfectly when you plug it back in and can check your work that way. You always want to check with the original, not with the one that you've changed. Okay. Now, like I said, I could have done this problem as an alternate way of doing it, just by getting rid of the decimals and multiplying everything by 4 in this case, because 2.25 is fourths and 0.75 is fourths as well. So watch what happens when I do that, just because of an alternate reality, right? If I had, let's say, 2 plus 1.25, f equals 10 minus 2.75 f, and I multiplied the entire thing by 4, then this is what it would look like. You would multiply the whole thing by a 4, and you would get, as a result, 8 plus 4 plus 1, which is 5, 5f, equals 40, and then minus, and that's 8 plus 3, so that would be 11, so minus 11, right? Because 4 times 2 is 8, and 4 times 0.75 is going to be 150 doubled, which is 3. So now we've got that, and that's 11f, I should say. Now what you're going to do is you're going to take that 11f, you're going to add 11f to both sides, and you're going to minus 8 to both sides. And what you end up getting there is 16f's is equal to 32. And divide by 16 both sides, and you get f is equal to 2, just like we got before. So just wanted to show you there that you have choices. You don't have to always do equations exactly the same way I'm doing them. What you do have to do, though, is you've got to be careful. You have to make sure that if you're going to multiply the entire equation, you multiply the entire equation all terms. And you also want to make sure that you're doing it in a way that's always maintaining the balance of the equation, right? So whatever you do one side, you always do the other. Remember, your goal is always to get the variables on one side and all the numbers to the other side, so you can isolate the variable and find its value. Okay? Hopefully that makes sense, and you guys feel pretty good. I'm going to put in f equals 2, and then we'll go to the next one. Okay, for the next problem, we have some fractions to work with here. So number 2, the fractions that we're working with are negative a 1/4 a, should say, negative 1/4 a minus 4 is equal to 7/4 a minus 3. Okay, so first double check to make sure you copied it correctly. I feel pretty good about that. You have fourths on both sides of this equation. So you want to get rid of the fourths. What I recommend you do is that you just multiply the whole thing by 4. That's what I would do first. And that means that 4 goes into 4 once. 1 times negative 1a is just negative a. 4 times negative 4 is negative 16. 4 goes into 4 once. 4 times 7a is going to just be, sorry, 7a is just going to be 7a. And then you have 4 times a negative 3, which is negative 12. Once you've done that, you want to get all your variables to the side that's going to make them positive. I think that's the easiest way to do it. So you'd add a to both sides. And at the same time, if you're going to bring your variables to the right, you want to bring your numbers to the other side. So that would add 12 to both sides. You get a 0 pair here. You get a 0 pair here. Negative 16 plus positive 12 is going to be negative 4. And 7a plus 1a is going to be 8a. You want the value of a, not 8a, so you're going to divide both sides by 8. How do you undo times by 8? Divide by 8. And you're going to get a is equal to negative 4 divided by 8, which is negative 1/2. There's your answer. So basically, if we could check this real quick, negative 1/4 times negative 1/2 is positive 1/8. So that's positive 1/8. You're going to minus 4 from that. And then that should be equal to over here, 7/4 times -1/2 is going to be negative 7/8. So that's negative 7/8. Let me write that a little later for you guys. Okay. Now, are these two values balanced? Are they the same? Well, a -4 plus 1/8, that's going to be the same as a -3 7/8. And negative 7/8 minus 3, or negative 7/8 plus -3 is going to be -3 7/8. So these are the same. And that just shows me you checked your work real quick. So the answer is, in fact, -1/2. So put negative space 1/2, and there's your answer. All right, let's do the next one. Hopefully this is getting easy for you guys as you see me go through the process. Number 3, let's do this one. You got 5c plus 16.5 equals 13.5 plus 10c. Now in this case, you could multiply everything by 10, but I think it actually works easier just to multiply everything by 2, right? Because these are both halves, right? 5/10 is half. So you might as well just double everything. You double everything, you're going to get rid of all your fractions, or decimals, I should say, and then we're good to go. So I would just multiply everything by 2. 2 times 5c is 10c. 2 times 16.5 is going to be 32 plus 1, which is 33. 2 times 13.5 is going to be 26 plus 1, which is 27. And 2 times 10c is plus 20c. You're now going to get all your c's to one side, all your numbers to the other. So I would take away 10c from both sides. And since I'm going to bring the variables to the right, I'm going to bring the numbers the other way. So I'd minus 27 or add negative 27 to both sides. Now you're going to get a 0 pair here. That's worth nothing. You're going to get a 0 pair here. That's worth nothing. And we can continue going from there. So 33 plus negative 27 is going to be positive 6. And here 20c minus 10c is going to be 10c. And we now have 6 is equal to 10c's. I want to undo times by 10, so divide by 10 both sides. And you're going to get c is equal to 0.6, or 6/10, right? Now that's a funky answer. It looks a little weird. So let's see if we can check it. So let's just do a little quick check. 5 times 0.6 is going to be 3. So is 3 plus 16.5 in fact equal to whatever's on this side? This is 13.5. And we're going to add to that 10 times 0.6, which is going to be 6. So this is going to be a sum of 19.5. This is also a sum of 19.5. So we check it. And we're done. We've checked our work. We know it works. We have the answer. So 0.6. We're good. And the last problem that we're going to do is this one here. So let's get comfortable with this one. This is number 4. This is 2 minus 2s is equal to 3/4 times s plus 13. And so I would get rid of the fourths by multiplying the whole thing by 4. That's an easy way to get rid of fourths, right? So you're going to times the entire equation by 4, all terms. And what you get is an equivalent equation, 8 minus 8s is equal to 3s plus 40 plus 12, which is 52. And so now you're going to get all your variables to one side. So I would add 8s to both sides. And if I'm going to bring the variables to the right, I'm going to bring the numbers the other way. So I have minus 52 to both sides, or add negative 52 to both sides. This becomes a 0 pair. This becomes a 0 pair. And what are you left with? 8 take away 52, the negative is going to win by how much? Well, what's 52 take away 8? That's 2 take away 2 gets you to 50, take away 6 more gets you to 46. No, 44. So we're looking at 44 on the left, and that's going to be a negative. And on the right, we're looking at 3s plus 8s, which is 11 s's. You don't want the value of 11 s's, you want the value of 1s. So how do you undo times by 11? Divide by 11 to both sides. You get s is now equal to negative 4. Once you have the answer, you're going to double check it, make sure it works by plugging it back into the original and seeing if you get a true statement. This is 2 minus 2 times negative 4. That's going to be plus 8. So really what we have here is 2 plus 8 on the left. On the right-hand side, you're going to have negative 4. So this is going to be 4 cancels out with 4. You get 1. This is 3 times negative 1, which is negative 3. So really on this side, what you get is negative 3 and then plus 13. So this is 10 on the left, and this is also 10 on the right, so it works. It's balanced. Now we've checked our work. We have evidence that we've checked our work, and I think we're pretty good on this stuff. Hopefully that makes sense to you guys. Let's put in our answer, and we're done. Negative 4, and now you know how to do these problems. Hope that was helpful.